Throughout the day, to the naked eye, it sometimes appears as if the sun changes sizes. But does it actually change size? Today, I'm going to test it. So we're using dateandtime.com to look up solar noon. You can see here's the website. It is February 27th at 10:03 a.m. I am in Scottsdale, Arizona. If we scroll down here, we can see that solar noon is at 12:40. Now I just set my alarm for 12:38. I'm going to go outside and take a picture of the sun as close to solar noon as possible. And then when I leave work today at 5 o'clock, I'm going to take another picture of the sun when it's much lower in the sky. It looks like it'll be close to an hour before sunset. So as you can see on this little chart, it's going to be substantially lower in the sky and much farther away. If the sun actually changes sizes during the day, we should see it in the measurements. So the setup we've got is the Nikon Coolpix P950 with an ND 100,000 filter on it. We can see the sun there. That filter there is going to eliminate pretty much all of the sun's glare, so we see the actual sun itself. This way, when we're measuring the sun and not the glare. So I'm a minute late. It's just past solar noon, but we're going to take this picture. So it's now 5:07. I'm going to take a picture now. We do have some cloud coverage, and I'm going to take my camera with me, and in about 30 minutes try again, just in case it clears up. So as you can see, it didn't clear up. Okay, so if we imported these into a folder. If you look here, we can see that the first one taken yesterday at 12:42 p.m., the second one at 5:09, and in case anybody is curious, I'll open the properties of these. So here they are side by side. We're going to go details here and see if there's any differences in this one. So the second picture with the clouds did slow the shutter down a tiny bit and increase the ISO. That was automatic, but you can see the focal length is the same, 35 millimeter focal length, 2000. So the zoom was the same, and the camera did auto adjust. The F was the same too. It auto adjusted the shutter speed and the ISO slightly, which those will not affect the size of anything at all if you know about photography. A slower shutter speed would cause more glare, but not this difference. So I duplicated them so we have the originals, and what we're going to do is open these in Paint. And essentially what we want to do is drag these so that they line up as perfectly as we can get them to the where the black and the sun meet. So we'll go zoom in just a little bit here. Bring that down a hair. It's close enough. And we're essentially going to do that with all four sides on both photos. And as you can see, there are times like this where we do have a little bit of like a haze right here. So I'll get it as close as I can to the edge. We can see a nice sunspot here. The rest of the sun was very naked all week. But down here we can see the size. So we've got 2489, 2485. Editor debunker here. I didn't realize that when I was recording this, I was cutting off the bottom like inch of the screen. So I'll show you the measurements on this tab here. So we can see the first picture, 2489 by 2485. The second one, 2499 by 2491. But I will show you where we see that in Paint. So you can see it down here at the bottom. And what we're going to do is plug those into an Excel spreadsheet. Okay, so there's our first one. Now let's do it with the second. It's the same thing. You can see with the clouds, it's very hazy. There's our sunspot. It's coming from here to there because we are changing our position and orientation of how we're looking at the sun. Okay, so there's our 5 p.m. one, 2499, 2491. So what I'm going to do is get the total pixel area. So pretty much just this times this, even though it's a circle and we cut it down to a square, I'm not going to stress too much about that. But these are our total pixel areas. Okay, so we're going to do two things here. We're going to see what the original, that is the change in pixel size. And then let's do the math of percentage change. So it's that minus that, and then divided by the new number. It's 0.64%. So that difference is extremely small. It's within normal atmospheric distortion and human error measuring margins. In other words, the sun's apparent size has no meaningful change throughout the day. And if anything, from my measurements, it's actually increased very slightly. So why does it look different in the day? There's two different things. One, when it's lower on the horizon, sometimes it looks bigger because our brain is comparing the sun or the glare of the sun that we see with other objects, houses, trees, buildings, stuff like that. And then as it sets, it starts to look smaller because we are getting cloud layer to block out the glare. So what we're actually seeing is less of the glare and more of the real sun right before the sun sets, the last 30 minutes or so. So if the sun were moving closer or farther away, like it would from sunrise, solar noon to sunset, the pixel measurements would change significantly. So as you saw here, we only had a 40,000 pixel area change. It would be substantially larger, and if the sun was moving away, this should have been in the negatives. But that doesn't happen. Measurements like this is a simple test that anyone can repeat. You look up solar noon for your location, you take one photo then, you take another photo later in the day, 3, 4, 7 p.m. right before sunset, and you measure the pixel diameter. You don't have to just trust claims that you see on the internet. You can measure it yourself.